So, in last class we talk about k nearest neighbor classifier. This classifier is good and many application it has been used, you can see also, and then main problem, it is not a problem, but how to find the value of the k. This is a main challenge you can say. Okay. So, you can take the value k equal to 1 to any values, but what is the exact value, and it varies from the data set to data set. Okay. So, there is no theoretical strong theoretical background formulation to how to choose the value of k, but there is empirical method to choose the value of k. So, therefore, today's topic will start talking about how to find the value of k. Ideally, what we do it here, as I said many times, we cannot use the test set for validating test set only for just validating the classifier, but we cannot use evaluate the classifier. So, but we cannot use the test set for any training purpose, or we cannot use the test set for finding any parameter. So, here k value is a parameter. So, we cannot use the test set. So, therefore, left over the only the training data set. What you can do out of this training data set, you can keep aside some training sample. Those training sample you cannot use for while identifying the class level of the objects. So, therefore, we can have the three type of sets. One is called training set, another is something called holdout, another is the test data set. But today in this class what we do it, suppose we have the, as I said, is because again you are taking away some sample for the holdout set. So, therefore, size of the training set might be reduced, obviously it will be reduced. So, therefore, what is done is that we use the cross validation set or finding k value using cross validation. Okay. Ideally, what we do it, we have the training data set here, and then test data set, we cannot use the test data set, as I said. Why I am saying it is repeatedly, to make you understand that this is the importance of the test data set. So, you can use only the test data set for evaluating the classifier, not for the any other purpose. Okay. So, now we have the training data set here. What you do it, we will partition the training data set into a number of folds. So, let us say this is one fold, this is another fold, this is another fold. Let us say this is the fold number D0, this is D1, this is D2, this is D3, this is D4, and then let us say D10. So, this is something called 10 fold. Now, what we do it, this D1 will be considered as test set, and then all D1, D2, D3 all will be considered as the training sample. This is already a training sample, but to distinguish the name from the test set, we will say this is something called the validation set. So, then in summary what happened, D0 is a validation set, and entire training data set is let us say T set. So, T minus D0 is actually training set. Now, what you do it, we will identify the class level of each object in the validation set. So, let us say there are 100 objects. So, obviously, each block, actually training data set is divided into a number of blocks. So, that is the validation set, each block is called the validation set. So, this is the validation set. So, that means, it is actually a test set, but to distinguish the name from the test set, we will give the name the validation set. Now, we will consider this one is the training set, and we will use D0 as the validation set, and we identify the class level. Let us say there is object, say let us say x block number 0 and another number is 0, x 0 0. You know the class level because it was the training data set, but all other objects D0 to D1 to D10, it will act as a training data set, as I said. What you have to do for finding the k values, you take the k value is 2 and identify the class level of the each object here. Either it will be right or wrong, as I say classifier will identify the class level rightly or wrongly. If it is wrong, so there is error, if it is right, so it is rightly classified. We will compute the error. So, there are 10 objects here, because if there are total 100 objects, each block consists of only 10 objects. So, out of these 10 objects, how many rightly classified and how many wrongly classified? Say wrongly classified is 6 for k equal to 2. So, we will take 6 k equal to 2. Now, again we move the same thing. Now, D 1 will be considered as the validation set, and the so in second case D 1 will be considered as a validation set, and D 1 rest of the thing, that is D 0, D 2, D 3, D 4, D 5, D 9 to D 9 will be considered as a training data set, and then we will try to identify the class level of each object in the validation set, that is D 1. And then there are also 10 objects. So, you identify the error with k equal to 2. Similarly, we do the same thing with D 3, D 4 and so on. Now, k equal to 2, not only that, we will repeat the same thing starting with D 0. What will be the error for k equal to 3? And we do the same thing with second block, third block and fourth validation set and so on. Similarly, we do k equal to 4 and 5 and so on, and we keep on doing the same thing, and then we will take the average error for the each value of the k. So, what was the average error or k equal to 2, what was the average error of k equal to 3, what was the average error for the k equal to 4, and wherever we will get the minimum error, that k value we will take. So, more elaborately next, let us say we will have a matrix like that. Here we say is k equal to 1, k equal to 2, k equal to 3, k equal to 4, k equal to 5 and up to some value k m, and this side will have a validation set, say how many fold. Let us say this is D 0 fold, this is D 1, this is D 2, this is D 3, this is D 4 and then this is D 9. So, now when D 0 will be the validation set, how many pattern or how many object in D 0 are wrongly classified, you write it here. So, instead of saying how many, you write the error rate. Error means out of 10 how many are wrongly classified. So, 3 are wrongly classified. So, error rate is 0.3. So, you write it here. So, that is we can say when validation set is 0 and k value is 1. Similarly, k equal to 2. So, and the same validation set error will be 0. Similarly, this will be error 03, error 04, error 05 and so on, and then error on the validation set 0 and k value is m. When D 1 is considered as the validation set, then error is noted as for the block 1 and the k value is 1. So, this will be 1 2, this will be 1 3, this will be 1 4 and then this will be 1 m. So, when D 2 is the validation set, so denoted as error for 2 1, 2 2, 2 3, 2 4, so a to m. So, for the ninth it will be E 9 1, E 9 2, E 9 3, E 9 4, so E 9 m. So, now this column, that is first column you can see. So, this column is responsible for the k equal to 1. So, you take the average. Okay. Let us say this value is something E 1 for the k equal to 1. So, second column with k equal to 2, you take the average and you get the value E 2. Then similarly, you do E 3, E 4 to E some value of m, let us say m equal to 25. Now, you find wherever the error is minimum, let us say some point here E 21 is the minimum error you got on the validation set. So, therefore, k value will be 21. So, ideally what you will see, if you draw this error with different values of k, let us say this is k. So, what is the error rate? So, you got the value, obviously you will get somewhere here, and e equal to 2 you will get somewhere here ideally. Similarly, e equal to 3 you will get, error will be getting decreasing when you are increasing the value of. So, maybe sometime it can be like that, and then it can be like that, and then there is a change of. So, here it may happen that this is 21 and you got the minimum error. So, then we consider that k equal to 21. Now, if you do not get like this type of curve, okay, very likely you will get this type of curve. If you do not get, let us say this is k and this is error, okay, that is we say. Now, it happened like that, you do not know actually something like that, and then obviously there is a chance that you can take this one, but if it happen like here, 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 it may happen like that. So, in that case there may be a problem with the training data set. So, your training data set is having some problem. So, you have to use some other training data set. So, this is all about how to choose the right value of k if you want to apply the k nearest neighbor classifier. Obviously, there are reason one I can explain with one example. You have 5 friends. Now, you are increasing the number of friends 100. Do you have contact with all 100 friends? Can I judge that 100 friends characteristics by you? I cannot judge. So, this is a simple example here. So, when neighbors, if you change the neighbor, if you said the whole world is my neighbors, I won't be judged by those neighbors, because see this is all, if you see the characteristics of the each data points and each object. Okay. So, when you include the 100, 500, 600 neighbors, that means you are actually including the points from the other classes. I belong to class A, I am including the points also other classes. So, therefore, and if you include much, if you include more, then you are including from the all other classes A, B, C, D classes, then my identity obviously will not be judged, lost, identity will be lost. So, obviously, that error will be more. So, next we will move to another classification algorithm, that is also quite old, but people they are using for domain, many people are using in this domain or various domain. Okay. So, that is something called weighted k nearest neighbor classifier. We talk about nearest neighbor classifier followed by the k nearest neighbor classifier, and then we are talking about the weighted k nearest neighbor classifier. So, here is the algorithm to find the value of k that I have already described. Let me once more follow it. So, partition the training data set into R block, that is I said is fold. So, R fold cross validation we can say. Okay. So, and then block number they have given T 1, T 2 to T R, because there are R blocks, and for I equal to 1 to R, for each block what you do, consider that particular block except the particular block, others all blocks you consider as the training data set and T I as the validation set. And then for a range of k values, as I said from 1 to m, find the error rates on the validation set. You have the validation set, and for each validation set you find the error rate, and let these error are E I 1, E I 2 to I m, and then what you do it, you take the mean of the each error for the different values of k, all column wise, as I mentioned few minutes before, and then you take the value of k wherever the value is minimum, k equal to 1, k equal to 2, and then k equal to m. Now, we will talk about the weighted k nearest neighbor classifier. So, weighted k NNC, k nearest neighbor classifier. So, just few minutes before we talk about the k nearest neighbor classifier. So, idea is very simple, that for the unseen object you compute the distance from the unseen object to the all other object in the training data set, and you choose the k closest object, okay, and you take the majority voting. That means, majority of the k nearest neighbor belongs to which class. and then that will be the class level of the unseen object. That was the main theme of the k nearest neighbor classifier. Now, there is one drawback here. They found KNN gives the equal importance to the first nearest neighbor to the last nearest neighbor. So, if you have 10 friends, it is really very difficult to give equal importance to all your 10 friends, right. You give some friends you give more, and then you very often you discuss your problem with your friends, or your joy, you share your joy with your friends. Maybe close friend is much better way, okay, than the others. So, you are saying that all are my close friend, but you are giving not equal importance to all your friends. Similarly, here we are saying that object is having k nearest neighbor, okay, but you should give importance the object which is close to the unseen object, and obviously within the k nearest neighbor the object which is far, but they are friends, but neighbors you give less importance. So, that is the basic idea of the weighted KNNC. So, that is you have to give weight to the each neighbors, that is the idea of the weighted k nearest neighbor. So, now how do you give the weight? Okay. So, that Dudani gave weight scheme is like, suppose you have the k nearest neighbor. Okay. Let us say I should move here we have much space. What we did it here, say suppose k is the unseen object, and then you have found the k nearest neighbor of the object x. No need to mention how to do it, because you are aware of all those. So, you find the KNN of the point x, and you got the point, say let us say x 21, x 22, x 51 and the x 64, 1 2 3 4 and x 69. So, you got the 5 k nearest neighbor. Okay. Now, you have to give weight. How do you give weight according to Dudani? What you do it? You compute the distance from x to the all its neighbor. You have already been you computed. Okay. So, let us say the closest neighbor is x 64. So, then you compute the distance and you got the distance d 1 with x 64, distance from the unseen object to the neighbors, and then you got the point x 51, and this distance is let us say d 2. So, here point is x 51, just to note it, okay. And then this distance is d 3 and then d 4 and d 5. You sort the point based on their distances from the ascending order, from the distances from the unseen object to the all its neighbors. So, obviously, you will get a ordered set d 1, d 2 to d 3, d 5. So, now the point which is closest, you give the maximum weightage. So, you give weightage 1 according to him, and the point which is at the last nearest neighbor, you give weightage 0, and the point in between you give the weightage between 1 and 0 excluding both the values. So, then what is the weightage formula? Say weight for a given any neighbors, j indicates the neighbors, whether d 1, d 2 or d 3, that is neighbors. So, first closest point we say is the first neighbor, second closest point we say the second neighbors, and so on. So, the jth neighbor weight will be something like that. So, first neighbor weighted will be d k, k is the k nearest neighbor distance minus d 1, d 1 is the distance from the unseen object to the first neighbor, and first neighbor it should be 1. So, this is something d k minus d j, this will be the weight. Now, if j equal to 1, this value will be, for the j equal to 1 means it is the first neighbor. So, then what will be the value? d k minus d 1 divided by d k minus d 1, this is minus means distance. Okay. So, then this will be 1 for the first neighbor, and what will be the distance from the kth, what will be the weightage for the kth neighbor? So, d j will be replaced by d k. So, this will be 0. So, that last neighbor will get 0 and the first neighbor will be getting weightage 1, and in between the value will be between 1 and 0 excluding both 0 and 1. So, here is the algorithm. So, let x be the set of KNN of the query point q whose class level is to be determined. that is we are considering x, so this is q. Now, you compute the distance d 1, d 2, d k be an ordered set, where d I is nothing but the distances from the unseen object to the each neighbor, okay, where x I, this x I belongs to, where x I belongs to this x. Now, weight W j is assigned to the jth nearest neighbor, as I said this is first neighbor, second neighbor and jth nearest neighbor is something like that. If it is not a first point, then this is the, and if it is a first point, this should be 1, d k minus d j by d k minus d 1. If it is also d j equals to 1, this also will give value 1. Okay. In between the value it will be 1 and 0. Now, what next? So, in case of the k nearest neighbor, what we did it? We have taken the majority voting, that means within the k nearest neighbor, how many points belongs to class A, how many points belongs to class C, how many points belongs to class C we have taken, and then the points which belongs to a class, that we have given the class level B, because the majority of the points belongs to class B. So, that was the idea of the k nearest neighbor, but here what we do it, we have the each point has the weight. Now, we will take the weighted sum across the weighted sum per class. So, we have 3 points here for the class A. Now, we will add this weighted. So, W 1, W 2 and W 3. So, under B how many points, again 3 points, we sum up this weight, and again we will sum up the for the class C, and wherever we will get the maximum value, that will be the class level for the unseen object. So, here calculate the weighted sum of the patterns belongs to each class. For each class we will compute the weighted sum and classify Q to a class which weighted sum is maximum. So, that is something called the weighted k nearest neighbor classifier. Decay is the distance to the kth nearest neighbor from the unseen object x to the kth nearest neighbor. Here we have decay, this decay and this decay is the same. So, we can stop here, we can take question offline.